Hello students, hello teachers, welcome to my YouTube channels. This is mathematics for grade 10 as Ethiopian curriculum for Ethiopian grade 10 students. Let us start from unit 1. I hope you will continue with me up to the end of the year. I will go through all of these textbooks and we will do examples and each exercises. So don't forget to subscribe and share my channel for your students or for your staffs and or any other learners. And I would like to say again, thanks for your appreciation. Bye. Let us keep going. Unit 1. Now, it says polynomial function. Polynomial function is a function that can have a form of px is equals to px is equals to an x the power of n plus an minus 1 x the power of n minus 1 plus an minus 2 x the power of n minus 2 plus continuous then plus ax plus a naught with n naught is greater than 0 and an x the power of n is the leading term and an is leading coefficient. This is the term total of an x the power of n is leading term and an is a leading coefficient, whereas a naught is constant term. And don't forget that an minus 1 an minus 2 and other terms between these sides are all a and a naught are also called coefficients. They are coefficients. The highest power or n, which means here this n is called degree of this polynomial. We can say it is a degree of polynomial. So any polynomial function must has n greater than 0, which means it's impossible to have negative exponents. So let us see polynomial function examples. Polynomial functions, the following functions are polynomial functions, which is 3x squared plus 5x minus 10. This is a quadratic polynomial. Let us say this one is a quadratic polynomial, which means with degree 2, with n is 2, and the leading coefficient is 3, and the leading term is 3x squared, and constant term is minus 10. Here we come to the second one, x to the power of 78 plus 44, degrees 78, and constant term is 44, and other terms are 0, and the leading term is this one, and leading coefficient is 1. C5. This is a constant polynomial function, which is constant function. So any linear functions, quadratic functions, constant functions are polynomial functions, we can say. And also this is a constant function which is a leading term is 1, and degree n is here, which is equals to 1, we can say. What about here? N is 0, n is 0 here, n is 0, and the leading terms also 0, and this one is constant functions, other terms are 0. Let us see some functions that are not polynomial again. 3x the power of minus 2. We have said that this is must be positive since n must be greater than or equals to 0. It's impossible to have negative exponents in polynomial function. Polynomial, it can't be polynomial functions. We have said that n is integer which is greater than or equal to 0, so this can't be also a polynomial functions. This one is undefined function, which means if x is 0. If x is 0, it can be undefined. This one is x is 0, is not x is equal to 0, is not the domain. It's not a domain. So if domain is not a real number, if domain is not a real number, that function can't be a polynomial function. Since polynomial functions domains always real numbers, and also let me see here, minus 24 into x the power of minus 1. Look the difference here, minus the power of minus 1 and normal x. Since one is negative exponent, it can't be a polynomial function. It can't be polynomial function. That's why we say this one is not polynomial function. Domain of polynomial function is a real number. Domain should be a real number. That's why this and this can't be polynomial functions. Also, this root function also has no its domain is not a real number, because root function domain is only positive integers, because this has only positive integers, which is positive integers is only the domain for root functions. We cannot consider negative integer exponent or fraction exponent or division as a polynomial functions. So we can say that we cannot consider negative integer exponents, which is, for example, example D here, you can consider here, and or fractional exponents or division as a polynomial function, which means if it is a form of a over b, it can't be also a polynomial function. Okay, let us come to exercise 1.2 from your textbooks, which says that which of the following are polynomial function. We are going to identify polynomial functions here. For example, this one is as a form of ax the power of n minus n minus 1 x the power of n minus 1, which is there is no negative exponent here, so it is a polynomial function. And what about this one? It also has a form of polynomial function. This one is not. sorry, this one is also, sorry, very sorry, this one is also polynomial function. It's also a polynomial function, but this one is not. This one is not polynomial function because it has negative exponents here, and this one is a fraction, which is a over b, or you can make this one up and it can be minus 2 exponent, which is, so this one is also not, but this can be, and this also it can be polynomial function. Here root is not considering x squared, so this can also be. So let us see what are their degrees, what are their leading term and constant terms as question number 2. If you take A, degrees, its degree is 4, which is its degree is 4, n is equals to 4, so this one is degree, and the leading coefficient is 3. Leading coefficient is 3 here. This one is a leading coefficient, and constant terms is minus 9. Constant term or a naught is minus 9. B, we have said it's a polynomial function, so degree is 25 is a highest exponent in the value of x, so n is equals to 25 is the degree, and the leading coefficient is 1. We have only one coefficient here, there is no any numbers here, so we can say leading coefficient is 1, and the constant term is also 1, which is 1. Let us come to D, which is f of y is equals to 1 over 3 y square plus 2 over 3 y plus 1. So n is equals to 2, which is, this one is degree. Degree is equals to 2, and leading coefficient is 1 over 3. This one is the leading coefficient, and this one is a constant term, so constant term is equals to 1, and leading coefficient is 1 over 3. F is also polynomial function, which is f of y equals to we can rewrite this one as minus 95 y plus 108. So this one is the leading term, coefficient, leading coefficient, and n minus 1 is y the power of minus 1, so n is degrees 1, and constant term is 108. Constant term is 108. So one is constant term for this function. We said also G is a polynomial function, so n is 3 here. So this one must be for h. This one is for h. It must be for h. N is equals to 3. We consider this one because we have to write in the order of descending order from highest degree to the lowest one. So n is equals to 3, and the leading coefficient is minus 1, not minus 3. Leading coefficient is minus 1. Here is a problem of writing, sorry. Leading coefficient must be 1 here, and the constant term is root of 2. So one is correct. And for G, we can say this one 380 is a leading term. N is equals to n is equals to 6, and leading coefficient is leading coefficient is equals to 312, and the constant term is 0. Constant term is 0 for G. We can say is for G here. So let us come to another from after G, I, which is given as f of x is equals to 3 under root x. So this can't be a polynomial function because its domain is not all number. For example, negative value can't be the domain here. Okay, if we see here also it can be fraction over before, so it can't be. This one is also it can't be polynomial function. The same way here, this one is not, domain is not a real number. Others, let's check. This one is also can't be because this is a fractional exponent here, so it can't take the value. And also this one is a form of a over b, and it's also its domain is not a real number, so it can't be a polynomial function. So you can say J N O Q R S and T are polynomial functions. They are polynomial function and also polynomial expression, we can say. And let us see their respective degrees, leading coefficients and constant terms. N is equals to 3 here. We should have to give the degree. N is equals to 3. Leading coefficients, which is minus 5 over 8, and constant term is 6 over 8, which is 6 over 8. When you make simplify, it can be 3 by 4, sorry. So when we come to n, leading n is degrees 1, x the power of 1 only. There is no another degree here. And the least leading coefficient is 1/12, which is 1 over 12, and the constant term is 0 here. This one is the leading coefficients, and the constant terms are 0 here. Okay, O, when we come to O, f of x is equals 0, so degree 0, leading coefficient also 0, constant term also 0. This constant function, so it is polynomial function with degree 0, leading coefficient 0, and constant term is 0. Don't forget that we have said that in polynomial function n must be greater than or equals to 0, which is inclusive. So it can be a polynomial function. Let us come to Q, which is degree is 83. Its degree is 83, and leading coefficient is 9 over 70, sorry, 9 over 70, and constant term is unknown because one is continuous. So continuous, you can write something here. For example, if you write 90, it should be 90 here. I hope it's not completed here, but maybe check your textbook. If there is any constant term, it can be constant term. And R here degree 0, because there is any terms that contain x or t. Since a function is as f of t, there is no any term that contain t, so n is 0. and the leading coefficient is 0. Leading coefficient is 0, which means if degree is 0, or for example, if we say 0 times x to the power of 0, we can say some constant term. So constant term is here 4 over 7 minus 2, which is equals to 7 4 minus 14, which is minus 10 over 7 is a constant term for this. S, when you come to S, you can multiply this one by this one, and by this one by this one, this one by this one, but we can get simply n x times x, which is 2, so its degree is 2. Leading coefficient is minus times positive, which is minus 1, and the constant term should be this one times 1, which is 2. And come to t, again in the same way, similar way, x can be by x, so n is 2, x square we can get, and leading coefficient, which is 1, because x times x will give us 1, and the constant term is minus 3 by 2 times 3 by 4, which is 3 can be cancelled by 3, so let me write here 2 by 3 times 3 by 4 is negative 1, so 3 can be cancelled by 3, you can get minus 1 by 2 as the correct answer. Okay, next time we will see operation on polynomial functions such as addition, subtraction, multiplication, and the divisions of polynomial function. So thank you for watching. Don't forget